Hello everyone. In this video, we'll look at some sensor projects that are easy to build and work on their own or with Home Assistant. The smaller one measures temperature and humidity and can be placed throughout your home. When connected to Home Assistant, it can provide a neat climate map of your living space, among other features. This one's only about $25 in parts, or even less if you omit the optional LCD display. The larger one measures 10 different environmental conditions such as air pressure, various gases, CO2, light, noise, and even movement. It has this attractive round LCD display, a QR code reader for configuration purposes, a night light, and more. In addition to the readings on the built-in display, it can also publish all of its data to Home Assistant. When you build devices yourself, there's fewer privacy concerns. You control your data, and you also control the code, which is open source. No company is going to brick these devices or decide they're no longer supported. They use off-the-shelf parts with code and documentation available for free on GitHub. So let's see how these devices work, how they're built, and how they can interact with Home Assistant. Let's start with the simpler temperature and humidity sensor. It has a small LCD display that normally shows temperature and humidity. Press the button to change to Celsius, and press again to display device information such as the IP address. You'll notice 4 different icons at the bottom of the main screen so you can tell what it's doing. These icons show that Wi-Fi is connected and that it's also taking sensor readings and publishing them using MQTT. MQTT is how we can send the sensor data to Home Assistant or other devices on our network, but more about that a little later. This device is designed to be inexpensive and easy to build. It uses a $7 Raspberry Pi Pico 2W microcontroller running CircuitPython. No Linux in this baby. A microcontroller is cheaper and starts up much faster than a single board computer, such as, say, a Raspberry Pi Zero. But you can still connect things like sensors and displays. Let's take a closer look at the actual sensor inside. It uses a Sensirion SHT40 temperature and humidity sensor that only costs $6 but is still quite accurate. It's connected to the Pico microcontroller using 4-wire I2C. The tiny screen is only about $8, but it's totally optional, so you could replace it with this $1 bi-color LED version, or just go without any indicator. It's housed inside a small piece of curved PVC pipe with a 3D printed top and bottom. That saves money on a case and saves the time it takes to print your own. And they're so cool looking. The STL files are available in the linked GitHub repo. Since these are so cheap, about $24 total in parts, you can place them all over your living space to see how your heating or cooling is performing. One in the kitchen, the garage, the basement, no display needed for this one, and the living room. Now that we have these strategically placed, we can configure Home Assistant to display the data all together. If you're not familiar with Home Assistant, the open source home automation platform, check out the link in the description. Anyway, with all of the sensors around the house publishing their data, we can design a dashboard such as this, letting us know the whole home temperature and humidity at a glance. I added the time of the last reading to make sure that all of the sensors are actually working. This screen is part of HA Dashboard, or is it a dashboard? I still haven't found out. That's optimized for wall displays, or is seen here on my Home Assistant wall dashboard. You can learn more about that panel in my other video. Even neater than that is the ability for Home Assistant to superimpose the readings on their location on a floor plan. You construct these floor plans in another program, such as Floor Planner, then export them into a Home Assistant dashboard and tell it where to display the readings. I have examples of how that configuration setup looks in the linked repo. Next, let's look at this monster of a sensor I nicknamed Beast. If you've made it this far, though, I just want to ask you to hit the like button and subscribe if you want to see more videos like these. Doing those 2 things really does help keep this channel going. This unit also runs on a Pi Pico microcontroller that's connected to the 9 onboard sensors and the display. The display cycles through the sensor readings automatically, or you can press the center button to advance it manually. Pressing the left button displays device information such as the IP address and software version, and the right button activates the QR reader mounted on the back of the unit. Since there's no keyboard, one of the ways to input commands and data is via QR codes. It recognizes QR codes that define a Wi-Fi connection, so you can simply hold your phone or a printed card here to set up the Wi-Fi. The QR reader is this compact $7 module from Useful Sensors that connects via I2C. You can see its flashing blue light that turns green when a QR code is read. Let's take a look at some of these sensors in action. The CO2 sensor, that's carbon dioxide, is sensitive to human respiration. If I breathe on this for a minute, we can see a rapid rise in this level. The CO2 level has almost doubled since I started breathing right into the sensor. The gas sensor is sensitive to carbon monoxide, volatile organic compounds, and alcohols. If I place a rag soaked in isopropyl alcohol on the sensor, we can see the value rise. In fact, it's now 12 times higher. The onboard particulate matter sensor, or PM, measures the concentration of soot, smoke, and ash particles in the air. If I blow a little soldering iron smoke into the sensor chamber, the particulate matter reading goes up dramatically. It's so sensitive it can even detect distant forest fires. When we send these sensor readings to Home Assistant, we can create a massive environmental dashboard that shows us all of the measurements and their history on one page. A few of the Beast's sensor readings are only visible via Home Assistant, such as the accelerometer that detects if the device is shaken, and the IR motion sensor, which detects movement in front of the device. So how do these devices send data to Home Assistant? As I've described in previous videos, I'm using MQTT, a lightweight network protocol for sending messages from one device to another. It's very popular for sending small bits of data from sensors like these to other devices. This utility, called MQTT Explorer, lets you see all of the MQTT messages flowing through my network from all of the connected devices. Each data message belongs to a particular topic. The sensors publish their data, and software such as Home Assistant can be configured to subscribe to certain topics. When it sees an update to a subscribed topic, it displays the new data on the dashboard. In fact, this beast is subscribed to a few MQTT topics itself, so we can send it messages to make it perform certain tasks. One is to turn on the cool blue LED inside. To demonstrate, I can manually send a message on the LED1 topic over the network. Since the beast is subscribed to that topic, it will process the message and turn on the LED. Home Assistant has a more streamlined way to do this using a dashboard element known as an MQTT button. I program the buttons to send the data for me when it's clicked, so anyone can use it without even knowing what MQTT is all about. For Home Assistant to recognize an MQTT sensor, you need to manually enter its details into your configuration YAML file. Here you can see where I've defined sensors and binary sensors for each relevant MQTT topic in my config file. Let's talk about these PVC cases. I wanted something with a relatively small footprint and that angled the screen up slightly for desktop viewing. I also didn't want to spend a lot of time designing and 3D printing a case. I decided to visit the hardware store and see what I could find. I was thrilled to discover many options in the pipe and fittings aisle. Actually, maybe too many options. Let's take a look inside the big sensor. The top is simply an acrylic security camera dome that I drilled some holes into. It protects the sensors inside and is secured by these small clips that I 3D printed. For a more permanent installation, you could screw these clips into the unit unless, like me, you're always taking it apart. The first thing we're going to do is remove the power connection. This uses a 5-volt 4-amp power supply with a barrel connector. The main board just slides out, but before we can remove it completely, there's a few connectors to disconnect. The white ribbon cable connects to the display. It's part of the iSpy system for connecting SPI displays and easily lifts out of the iSpy breakout board. Next, I'm removing the Quick or STEMMA-QT connector for the QR code reader mounted on the case. That's a 4-wire I2C bus. Next, I'm disconnecting the 3-pin JST connector for the push buttons that are located below the display. The main board is just a metallic grid where everything is mounted using spacers and standoffs. Here at the top, we have the SCD40 CO2 sensor. The large blue box is the particulate sensor. It uses a laser internally to count the number of microscopic particles that are suspended in the air. Up at the top is the gas sensor. It outputs an analog signal that is converted to a relative value between 0 and 100 by the Pico's analog to digital converter, located down here. For sound detection, we're using an electret microphone that's also connected to an analog to digital converter to get a relative value between 0 and 100. Next, the light sensor provides a reading for the level of ambient light in lux, the standardized unit for light. You can see here that most of the sensors are connected together using Quick or STEMMA-QT connectors. Here in the center is an accelerometer that can detect when the device itself is moved or shaken. Right now it just provides a yes/no value, but there's plenty more it could be programmed to do. As I mentioned before when I removed the display's ribbon cable, this is the iSpy breakout board that conveniently connects the display to the Pico. On the other side of the board we have the blue LED mounting assembly and the main power connector on a 3D printed harness that normally faces downward. This part of the board rests on a small 3D printed bracket you can see here in the base of the unit. The 3D printed control panel is designed to snap into place, but we can pop it out to look at the other side. You can see the display and buttons mounted to a generic perf board. You can also see the display's ribbon cable, as well as the wires for the 3 push-button controls. It took a lot of trial and error to get the sizing and layout for these just right. Here are some of the designs that just didn't quite fit. The STL file for the one that does fit is in the linked repo. So what does it take to build these? Well, you probably want to start by making a mock-up or breadboard out of the circuit. The parts list and schematic diagram are in the repo. As mentioned earlier, these units are running CircuitPython, so download the appropriate version for the Pico 2W and follow the instructions to install it. You'll find all of the files needed for the project, as well as general instructions and helpful photos in the GitHub repository. To prepare the PVC parts, there's some light drilling and also 3D printing of panels and brackets. Finally, for permanent installations, some soldering is required. Think of the information presented here as an inspiration for creating your own sensor projects. There's dozens of other sensors you could use and experiment with, as well as tons of different form factors for cases. In addition, Home Assistant has many more dashboard features than what I've presented here, which merely scratches the surface. The main takeaway is to have fun and just start building stuff. If not with this project, then one of the many others you can find online. So that's it for now. Thanks for watching, and please subscribe so you don't miss my next video.